Welcome back, guys. In this video tutorial I'm going to show you how to set up a sensor that is BMP180. To know more this sensor, let's move on to our website controleverything.com and let's have an overall look over this sensor and search this sensor. So we have this sensor BMP180, which is a digital pressure sensor. The range of this sensor is 300 to 1100 hectopascal, and these are some of its features which you can see on my screen. You can purchase this sensor from here. Further, I will be interfacing this sensor with a Raspberry Pi and a Java code. So for that I have to get the Java code. So let's have a look over the resource tab, and here is our Java code sample. You can download the Java code sample as zip file from here. The link is provided below. Now you can have the privilege to download the code from our GitHub repository, that is Control Everything community. You have the chance to get it from here. So you have two ways by which either of you can get the code. So now next we have to set up the device and the hardware and the connections we require for this particular video. So why not we have a look over that. The sensor which you see on my screen is a digital pressure sensor BMP180. Now to make a further connection, we need a Raspberry Pi, which you are able to see on my screen. Now these are the GPI pins of the Raspberry Pi. Now to make a connection among the sensor and the Raspberry Pi and a lot more other I2C devices, and to make this connection a lot easier, we need this I2C shield. This is available on our website controleverything.com, and gently press the I2C shield over the Raspberry Pi GPI pins and make this connection. Hence we are done with the connections part, and now the binding factor to make a connection with the sensor and the shield, we need this connecting cable. Now make the connection of the cable and the sensor and make it sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same set of rules had to be applied for the I2C shield. Now our connections are done. Now we need to power up our Raspberry Pi. Hence we need a micro USB cable just like this. Gently put it over the power jack and light it up. Next, for an internet connection, there are two ways to get it done. First of all, this is an Ethernet cable. You can put it over the Ethernet jack to make an internet connection. In case if you don't have, you can go for the second way, which is a wireless USB nano adapter, which makes a lot easier your job. Hence, this is the final connections we need with all the hardware we require. Next, we need to explain and interface the code with the sensor, and let me explain the working to you. So let's proceed further. Now we are done with the hardware connections part. Why not we have look over the code and do we interface with our sensor. So for that we require the Java code, and first of all we have to log into github.com and here search for the repository, that is Control Everything community. Now click over it and here type in BMP180 and here comes our sensor. Now this is the required Java code. Let's have a look over the instructions for this Java code. We have downloaded and installed Pi4j library, and you too have to same, as we have used this particular library on our code, and this is a link provided here. Open up the link so that you can have a better look for this particular installation. This is all the required library and the particular information for the installation purpose. Go through it and have a look over it. Now get back to the code, and here comes the code, and it's a .java extension file. The first thing you notice that we have included some of the libraries which we will require and the functionalities in them. We have created a public class named BMP180, and the device bus.getDevice will have the address of the sensor, that is 0x77. We have calibration coefficient stored in EEPROM of the device, and we have read 22 bytes of the data from 0xAA, that is 117, the decimal equivalent. As you can see, we have the conversion of this particular data which we have read a lot earlier. Now coming to the writing section, we have selected measurement control register and enable temperature measurement, and the command for them are 0xF4 and 0x2E respectively. Now we have read 2 bytes of the data from address 0xF6. This is the temperature data we have read. As you can see, 2 bytes, temp MSV, temp LSV. Now we are reading the data continuously, and the conversion of this particular data takes place here for the temperature, and it's according to the data sheet for BMP180. Similarly, we have followed the suit and selected the measurement control register, that is 0xF4, and enabled pressure measurement along with OSS equal to 1. Now again, we have read 3 bytes of data from 0xF6, that's the pressure data, MSB1, MSB and LSB. We have been continuously reading this data and converting here for the pressure, again which is according to the data sheet. Well, this is the calibration for temperature, calibration for pressure. As you can see, this is all according, and at this end we have the third entity, that is altitude. We have the calculation part of this altitude, which is why we have used the pressure and the math function here. At the very end of our code, we have the output data on the screen, and we have formatted it as you can see. Altitude in meters, pressure in hectopascal, temperature in Celsius and Fahrenheit, and all the values are being formatted to 2 places of float values. So this is how the correction is being done, and the generalized code is here. So let's have a look over it again, as you can see, so to clarify it a lot better. Now as you're done with the code, let's have a look why it works and how it works. Now let's have a view over the working for this particular code and sensor, and for that copy this entire code and open up the Raspberry terminal. Here create a new file, BMP180.java extension, as you can see, and paste this entire code and save it. Now this is the command to compile the code, as you can notice, and the code is being compiled. It might take some while, so let's wait up, and it's done. Good to know that it's done early. So now this is the command to run the code, and here we go. It's altitude, pressure and temperature. As you can see, when I again run the command, there's a slight change. Now when I apply pressure over the sensor and run the command for that, there's a change in altitude, pressure and temperature, as you can notice. Now when I again do that, there's again change again, as you can notice. So this is how the Java code works with this particular sensor of BMP180 digital pressure sensor, which includes temperature and altitude also. So let's have a look over the benefits, the features, and why we use this in a lot of applications. As of now, we have seen the hardware connections, the explanation of the code, and the working of this particular sensor, that BMP180. The BMP180 is a digital pressure sensor. It is the functional compatible successor of BMP085, a new generation of high precision digital pressure sensors for consumer applications. The ultra low power, low voltage electronics with a low altitude noise of merely 0.25 meter at fast conversion time, the BMP180 offers superior performance. The BMP180 is based on piezo-resistive technology for EMC robustness, high accuracy and linearity, as well as long-term stabilities. The applications include enhancement of GPS navigation, in and outdoor navigation, leisure, and supports weather forecast, vertical velocity indication, and a lot more. So we have set up a digital pressure sensor, that is BMP180. So I just thought that I would make it clear in case you are in a kind of thought that you are left without fully understanding this particular thing, the explanation, the connections, or any part of this particular video. So post your queries on controleverything.com, and you can post them on our community page. Now for blogs and articles which are relevant to this video tutorial, you can go to instructables.com for the communication, and to subscribe more video tutorials like this, you can subscribe our YouTube channel. Now I hope you enjoyed this video a lot and have a good one for yourself also. Thanks a lot for watching.